Hello, everyone. In this video, we will review the relationships between different types of insurance that we have covered so far with more examples. First, we have the expected value of an N-year endowment insurance. This equals the expected value of an N-year term insurance plus the N-year period endowment. And this relationship also applies to the second moment. The notation for the period endowment is NEX. The corresponding second moment for the period endowment is NEX with superscript 2. And then we have the relationship for the whole life insurance. The expected value, AX, equals to the expected value of an N-year term insurance plus the N-year deferred whole life insurance. This also applies to the second moment. And then for the N-year deferred insurance, N bar AX, this equals to a whole life insurance on HX plus N and then discount back. And we have this relationship. And this also applies to the second moment. The expression UN NPX is simply the period endowment NEX. And then the second moment, U2N NPX is the second moment for the period endowment. We have N by AX equals to this expression. And for AX, we have this expression. Next, we will build up a relationship for period endowment. NEX, $1 survival benefit, discount back. And this NEX can be decomposed into two period endowment. We can discount this $1 from HX plus N back to HX plus T. And we have this expression, and then further discount back to HX. UN minus T times N minus T PX plus T is N minus T EX plus T. The N minus T year period endowment. And then UT per X is the T year period endowment. And therefore, NEX equals TEX times N minus TEX plus T. All right, so let's take a look at a series of examples. Mortality follows the standard ultimate life table, and I is 0.05. Calculate the actuarial present value of a 15-year endowment insurance of $500 issued on a person at age 40. We need to get this quantity, 500 times A40 colon angle 15. Make use of the relationship and see if we can get the values from the table. Okay, the AX, and then the second moment, the 10-year endowment insurance, the 20-year endowment insurance, and then the period endowments. A40 colon angle 15 can be expressed as this. A 15-year term insurance on age 40 plus the 15-year period endowment. The 15-year term insurance equals to A40 minus 15-year 40 times A55. And then how about 15-year 40? We only have the period endowment for 5-year, 10-year, and 20-year period only. And now we're having a 15-year period endowment. We can decompose 15E40 as 5E40 times 10E45, or 10E40 times 5E50, or a product of 3 5-year endowments, 5E40, 5E45, 5E50. And in this solution, we make use of this expression. 15E40 equals 5E40 times 10E45. We get 5E40, 0.78113. And then 10E45, we get 0.60655. Multiply them together, we get 15E40 as 0.473794. Or else we can make use of the two quantity, 10E40 times 5E50. And you should get a similar result. Or 5E40 times 5E45 times 5E50. Multiply these three numbers, and you will get a number close to 0.473 as well. All right, so we get back to the expression here. We need A40, we get 0.12106. And then we need A55. All right, so we get all the quantities required. A40, and then minus 15E40 times A55. And then plus 15E40. And we get this 15-year endowment insurance, 0.483399. And then we need to take 500 times this quantity, and we get the answer, 241.7. Let's take a look at another example. From the standard ultimate life table with interest rate 0.05, calculate the second moment of a 10-year endowment insurance on a person at age 34. We get the relationship related to the second moment. So we need this expression. And we also need this expression to get the second moment of the 10-year term insurance. All right, from the second expression, we can get the second moment of age 34 here. And the second moment here for the whole life insurance at age 44 as well. And then the second moment of the pure endowment, which equals to U20 times 10P34. And then we get an expression, U10 times 10E34, and we can get 10E34 from this column. And therefore, we can get the pre-superscript to 10E34, which equals 0.375. And then we can get the 10-year term insurance, the second moment. The pre-superscript to A34, and then minus the last quantities here. We get 0.002847. This is the second moment for the 10-year term insurance. And then get back to the first expression. And we get the answer. All right, let's take a look at another example. There are 3 insurance policies. The first one, Z1 is the present value random variable for a 10-year term insurance of 20. The expected value of this insurance is 1.57 and the variance is 23.9. The second policy, a 10-year deferred whole life insurance of 80. The expected value 9.7 and the variance is 194.94. The third policy, a whole life insurance of 80, and we want to get the variance of Z3. The notation, the first policy, the notation is 20, and then the 10-year term insurance. And then the second policy, benefit 80 times the 10-year deferred whole life insurance. And Z3 is 80 times AX. Related to 3 policy, 80 times AX. AX can be written as the sum of a 10-year term insurance plus the 10-year deferred insurance. And this can be further decomposed to this. We have the 20 times this big A notation, which is the first policy. And then the second term here is the second policy here. Therefore, we can express Z3 as 4Z1 plus Z2. And we want to get the variance of Z3, which equals the variance of 4Z1 plus Z2. By definition, this equals to the variance of 4Z1 plus variance of Z2 plus 2 times the covariance of 4Z1 and Z2. Factor out the constant. And we need to get the covariance. The covariance of Z1 and Z2 equals to the expected value of Z1 times Z2 minus the product of the expected value of Z1 and the expected value of Z2. So what is Z1 times Z2? Z1 is a 10-year term insurance. That is, the death benefit only pays if the individual dies within the 10-year period. And then Z2 is a 10-year deferred whole life insurance. There's no death benefit in the first 10-year period during the 10-year deferred period. Therefore, the stream of benefits between Z1 and Z2 has no overlap, and therefore Z1 times Z2 is 0, and the corresponding expected value of Z1, Z2 is 0. So the covariance of Z1, Z2 is simply the negative of the expected value of Z1 times the expected value of Z2. We are given all these 4 quantities. Variance of Z1, we get 23.9. Variance of Z2, 194.94. The 2 expected values, 1.57 and 9.7. And upon calculation, we get the answer. The variance of Z3 is 455.51. All right, that's it for today's video. Thank you for watching and see you in the next video.